Bismillahirrahmanirrahim. In this lecture, I will discuss the next question, question number 8, related with the practical example of a differential equation relevant with FSC Part 2 Mathematics KPK board. So let's move toward FSC Part 2 Mathematics KPK board, exercise number 9.2, chapter number 9, differential equation. This is the practical example of a differential equation used in our daily life. It tells that a particle moves along x-axis, so that its velocity at any point is equal to the half its abscissa minus 3 times the time. At time t is equal to 2, x is equal to negative 4, determine the motion of a particle along x-axis. Move to solution. The first thing that is very important is the velocity at any point is equal to the velocity v, represented by v, which is equal to the half its abscissa. What is abscissa? Let's suppose we have 2 points x and y. This is another pair palm. So this first is called abscissa and the second y is called ordinate. So that tells that velocity at any point v is equal to half its abscissa. Abscissa is x, so it means half of x, which is equal to x by 2 minus 3 times the time t. After this, they tell that at a time t is equal to 2, x is equal to negative 4, time is equal to 2, x is equal to negative 4, determine the motion of a particle. So we are going to find the motion of the particle. So over here, remember, velocity is actually equal to the displacement covered by a body in a unit time. So over here, we have two variables x and t. So the displacement will be x and the time is t. So it means velocity is equal to the first time derivative. The first time derivative of the distance displacement x with respect to the first time derivative of the time is equal to x by 2 minus 3t. From over here we cannot solve this differential equation. So over here I shift x by 2 on this side, it becomes dx by dt. It becomes minus x by 2, which is equal to minus 3t. Now over here, comparing this with this palm, dx, let's suppose equation 1. Comparing with dx by dt plus p of x is equal to q. Let's suppose this is 2. From where dx by dt in both equations is same. Coefficient of x over here is minus 1 over 2 and over here the coefficient of x is p. If p is minus 1 over 2. And on the right hand side q is minus 3t by comparing. So over here first we will find the integrating factor. Integrating factor is equal to, this is the formula, integral power of p of dt. So over here it becomes e power integral of p. P is minus 1 over 2, so it becomes minus 1 over 2 dt. So by solving this it becomes e power minus 1 over 2 is a constant, integration of dt is t. It becomes minus t by 2. This is integrating factor. Now how can we find the solution to this type of differential equation? This is the simple formula. Multiplying this x with the integrating factor on the left hand side, this will be equal to the integral of integrating factor multiply right hand side, which is actually q into dt. Now over here x comes down as it is. Integrating factor is e power minus t by 2, which is equal to the integrating factor, which is e power minus t by 2 into q. Q is minus 3t, so it becomes minus 3 dt. Further it becomes x e power minus t by 2. Minus 3 is a constant, we will write it outside of the integral. Inside we left with t into e power minus t by 2 into dt. Over here use integration by first function and second. So by solving it becomes x e power minus t by 2 is equal to minus 3 times of first function integral of second. Its integration is e power minus t by 2 divided by its integration is minus 1 over 2. Minus integral derivative of the first function t is 1. Integral of this function is e power minus t by 2 over minus 2 by 2 into dt. Now further simplify it becomes x into e power minus t by 2, which is equal to minus 3 into, it becomes minus 2t into e power minus t by 2. Minus 2t e power minus t by 2, it becomes minus gives us plus 2. So plus 2 integration of e power minus 2t, again e power minus 2 by t by 2 over minus 1 over 2. So it becomes x e power minus t by 2, which is equal to minus gives us 6t e power minus t by 2 over here 2 into 2 gives us 4. 4 into 3, it gives us 12, minus minus plus. So plus 12. So plus 12 e power minus t by 2 and plus constant of integration. So 6t e power minus t by 2, 3 into 2, 6, 6 into 2, 12, e power minus t by 2 and plus constant of integration. Now, this is actually passing from x is equal to negative 4 and t is equal to t. So over here x is actually minus 4, so minus 4 into e power minus t by 2. So over here I simplify it further by removing this e power minus t by 2. So multiply x e power t by 2 to the both sides, it becomes x, so it becomes 60, it becomes 12, and it becomes e power minus t by 2 into c. Now this is easy. Putting the values, x is minus 4, so minus 4 is equal to 6 into t, t is 2. So 6 into 2 gives us 12, and plus 12, and plus e power minus t, t is actually 2. So 2 by 2 will give us 1, e power negative 1 into c. So it becomes 24. By shifting to this side, it becomes minus 4 minus 24 gives us minus 28, and divide with e power negative 1. So it becomes e power negative 1 is equal to c. So the required value of c is minus 28e. Now by putting this value over here, it will give us the required equation of motion, which is x of t is equal to 6 times of t plus 12 plus e power minus t by 2 into c. C is minus 28e. This is actually the required equation of motion, and this is the required answer.